Okay, we have several possibilities here for a t-test. Let's start with looking for an outcome variable. So we want to look for a scale or ratio interval variable, something with meaningful numbers and lots of data. I think your number of graduates is probably a good call on that, especially since you're not quite sure what this is referring to. This is something we can be fairly clear about. So now we need to find some way to divide all these institutions into two groups. Now, not every institution has to fall into one of those two groups, but we're going to analyze the difference between the two groups. Let's do something with gender. You could do a similar thing with ethnicity. What I'm going to do is insert one to the right here. Let's get percent female. So female is clearly the dominant gender of students in these programs, which makes sense. What I'm going to do is I need the percent female. So that would be the number of females divided by the total students for which we have gender data. Now the reason I'm doing that instead of using like total students over there or something is because I want to make sure that like you had said, there was some inconsistency where not all the parts of the data matched up. So this way we're only using this one part of the data, so at least it's internally consistent with itself. And if I close that parentheses, press enter, I get the percent female. If I drag this down, we're going to get lots of nasty division by zero arrows, but that's okay. And then I just want to make that a little cleaner, so I'm going to change that to a percent. So there, for the ones we do have data on, we have the percent of their students that are females. Let's go ahead and get this into a tab. Call this Week 7 tab. And so what I'm going to do is I'm going to maybe grab the institution data, we'll cut and paste here, and then I'm going to grab the percent female data. When I paste this, watch what happens if I just try to paste it. If I just paste it directly, it's going to give me all these errors because I was referring to cells that came before it. So what I want to do instead is paste special values only. That'll change these to numbers. And then I need that outcome variable, which would be the number of graduates. Okay, and then I can get rid of these top two rows, and just to make this easier, I'm going to go ahead and freeze that top row. Okay, so now we have the percent female, total number of graduates. The sum here isn't really important, so I'm going to get rid of these also. And in fact, I don't have data here, so I could do two interesting divisions I'm thinking of. One would be dividing the institutions into ones that have data and ones that don't. Those could be my two groups. So the way I would do that is if I throw a filter on here, sort A to Z, all of these with data would pop to the top, and the rest of these would be down here. So I could make this my data for the first group, and this my data for the second group, and that would be looking at is there a difference in average number of graduates between schools who report the gender data and schools who do not report the gender data. That could be a two-tailed test there. Or I could take a look just within these. I'll let you decide if you want to do that. I'm going to go ahead and delete them off. So I now only have the ones that I have data on, and in fact, I'm not going to be able to use these because I don't have the number of graduates data. So I'm going to delete those two rows also. we're down to a pretty small sample size, but that's actually okay. The t-tests came from William Gossett 100 years ago, working for Guinness Brewery, and the whole point of him doing t-tests was that he didn't want to crack open too many barrels of beer. He wanted to be able to work with small sample sizes. So the t-tests actually do work fine with small sample sizes. And let's say, what would be a natural? Maybe we could say 90%. So we're looking at these schools right here versus these schools right here. So these would be the ones that are almost entirely female, and these are the ones that are more male or transgender. And we could see if there's an average number of graduates, difference in the average number of graduates between those two types of college. So that would be one way. You could do a similar thing for race, where you look at the percent of non-white students. You could also, like I said, do the ones that have data, the ones that don't. If you knew a lot about the institutions, you could by hand code, for example, private, public. You would just put in a new variable here. Maybe you say public 1, private 0, and then you would just go down here, and I don't know most of these colleges, but if you could do even a good portion of those, you could Google the rest. That would also allow you to divide, is there a difference between public and private institutions in terms of the number of students who graduate there. I think that was their RN program. I forget exactly which program that was. So that gives you some ideas. You could do schools who have any American Indian students versus schools who don't have any. That doesn't seem quite as meaningful worded like that. Any way that you can divide these institutions. You could do top half of the state versus bottom half of the state, or maybe looking at geographic. You could do rural versus urban, suburban, if, again, you were able to kind of go through and maybe you know a bunch of these off the top of your head, and then you could Google the rest. Any way that you can divide these into two meaningful groups, potentially throwing off some that don't have the data, that's fine. Even if you have 3 or 4 in each group, it's not ideal. It may not meet the assumptions of the test, and that's okay. For this, I just want you going through the motions of t-test, an unpaired t-test. So let me know if you have further questions.